Hello, dear students. Mr. Lawrence here, and we are factoring trinomials by grouping where the lead coefficient is now 1. Day 2. We're going to get right down to it. We're going to actually do 8 problems this time. I'll do them as quickly as I can. You should be writing down notes. Shouldn't just be watching. Did you hear that, Zach? Anyway, the purpose of the last 4 problems is to speed you up. We're going to show you some special patterns that don't require all this work, okay? And I know some people were learning them from other students, and I don't mind you learning them from other students, but please be careful to not undermine what I'm trying to do as teaching. We don't want to learn too soon because then we don't master the techniques of how to do the ones that don't fit the special patterns. Okay, so anyway, let's get down to business here. I've got this problem, number 1, 21x squared plus 5x minus 6. And I'm just trying to move everything over here to give myself a little more room. Hold on 1 second. There we go. Okay, so let's do this. I've got to multiply 6 times 21, and I believe that's going to be 126. I'm going to need 2 factors of 126 that subtract to get 5, positive 5. Now, if you can see the factors right away, you can go right to them. I don't happen to see them. I don't know factors of 126 that well, but I do know that the 2 factors have to be within 5 of each other, right? Because they're going to subtract to get an answer of 5. So I know I'm not going to use one. Uh-oh, airliner trouble. Sorry about that, some technical difficulties. Anyway, I was about to say that I know I'm not going to use the factors of 1 and 126. Now, because I don't know all the factors of 126 off the top of my head, I'm probably going to go ahead and list them out just to make sure, but I'm not even going to consider this one. I'm going to list it so I don't miss anything, but there's no way they're even close. 2's not going to work either. What are we talking about, 63 there? Okay, let's see, 3's going to work, but you know what? I'm going to jump down here. I know 9's going to go in. I'm going to see what happens with 9. See, 9's going to go into 12 once. 14. Look at that. They're 5 apart from each other. See, I didn't want to list 3 and 4 and all that stuff. 6 would work. So 9 and 14. Now I need a positive 5, so it looks like it would be 14 minus 9. So I'm going to rewrite my trinomial. 21x squared plus 14x minus 9x minus 6. And then I'll go ahead and group, grabbing the sign, pull out my GCF. First quantity looks like it's going to be a 7x. I'll get 3x plus 2, and then I'll pull out a negative 3. 3x plus 2 is left, and we'll get 3x plus 2 times the quantity is 7x minus 3. And there you go. See, I didn't waste my time listing all the factors, I just kind of used some common sense. Okay, now in this one, before I multiply 12 times 12, you know what? I just noticed something. I've got a 12x squared here, an 18x, and a 12. I see a GCF. You see it? I think it's going to be 6. I can factor out a GCF from the trinomial, get 2x squared plus 3x minus 2. And now I'm going to multiply, but I'm going to multiply the two 2's together. Yeah, right here. I'm going to rewrite this as a polynomial with 4 terms. Instead of the other one, it'll be easier to work with. So when I multiply 2 times 2, I get 4. And I'm going to subtract my factors of 4 to get 3, positive 3. Sounds like 4 minus 1 to me. So I didn't even need to list them all out. So I've got to bring down the 6. The 6 comes along for the ride. And I will have 2x squared plus 4x minus x minus 2, right? Now, with inside that quantity, I'm going to group the first two, and I'm going to group the second two, grabbing the sign, and stick a plus in there. Okay, that 6 stays out front. He's not going anywhere. Okay, so I'm actually going to change this parenthesis to a bracket, and I'm going to GCF this. So I'm going to pull out a 2x, x plus 2, right? And then here I'm going to pull out a negative 1. And I'll be left with an x plus 2. And now I'm going to close my bracket. Okay, why did I change to a bracket? Just so you can tell the difference between the parentheses and the brackets. So now I'm still working inside. I got my 6 out front. Okay, I'm going to have this bracket. I'm going to factor out this GCF and get an x plus 2. And then I'll be left with a 2x minus a 1. Okay. Now the best answer wouldn't have this extra set of brackets in it because they're unnecessary now. I needed them to help me understand what was going on, but here's my best answer. So I GCF the trinomial first. You know what? It's just a smart idea to check for a GCF first. The other problems we've done didn't have one. Look at problem number 3. 10x squared minus 10x minus 20. I see a GCF. It's 10. I'm going to pull it out. Okay, I'll be left with x squared minus x minus 2. A lot easier to work with this than it is to work with that. Okay, so I multiply 1 times 2, and I get 2. Remember, there's a 1 here, right? Okay, and there's only 2 factors of 2. I need to subtract them to get negative 1. Oh, how about 1 minus 2? So I'm going to rewrite this. X squared plus x minus 2x minus 2. I have a 10. I'm going to group inside here like this. So I'm going to get x times the quantity of x plus 1 minus 2 times the quantity of x plus 1. All right, I've got 10. I'm going to pull this x plus 1 out. I'll be left with x minus 2. The best answer would be this because it's simpler. And there we go. All right, number 4. You think there's going to be a GCF in there? You bet your boots there's going to be a GCF hiding in there. I'm thinking that maybe 12. Yeah, 12's going to work. All right, so I'm going to pull a 12 out. And I'll be left with a 2x squared minus, let's see, 5 would be, 5 times 12 is 60, right? Okay, so 7 would be 24 more, 84. Yeah, so it's going to be 7. Okay, plus 3. 2 times 3 is 6, right? So I'm going to need 2 factors of 6 that add to get negative 7. Well, how about a negative 1 and a negative 6? So I'm going to write 12, 2x squared, minus 6, x minus 1, x plus 3. Okay, so I'm going to have 12. Time to group. Got to stick that plus sign in there. Okay, it looks like a 2x is my GCF of that first quantity. Be left with x minus 3. Now, I don't see a GCF here, but I look, I've got a negative x plus a 3, and I need an x minus a 3. So therefore, I will pull out a negative 1. When I pull that negative 1 out, I'll get x minus 3. All right, I'm going to have a 12, and then I'm going to have the quantity of x minus 3 right there. And I'll be left with the 2x minus the 1. There you go. Pretty easy stuff. Okay, let's look at some special patterns here. Now, there's no GCF hiding in these. Yeah, there's no GCF. But if I go to factor number 5, I can do it super quick. In fact, I know number 5 is going to factor like this. How do you suppose I did that so fast? Well, what do you know about 49? Hopefully you're thinking it's a perfect square. What's the square root? It's 7. We're only dealing with the positive square root here. What's the square root of 3x squared? 9x squared? Well, it's 3x, right? Did you see that? The square roots show up in the problem. Okay? Now, here's the part that's important. You'll notice that, but you got to be careful to not overgeneralize. I want you to multiply these two together, and of course you get 21x, right? And then I want you to double it, 42x. Disregarding the sign, it matches, doesn't it? If that's the case, this is called a perfect square trinomial. Very special. Very easy to factor. Okay? You take the square root of the first term, it becomes the firsts in the two quantities. You take the square root of the constant, it becomes the lasts of the two quantities. There has to be a plus here. This sign shows up in both quantities. Boom, I'm done. Okay. Number 6. Let's see, is 25 a perfect square? It sure is. Is 64x squared a perfect square? Yes, it is. Okay. Well, let's multiply. I get 40x times 2 is 80x. And look at that. It matches, doesn't it? If it didn't match, I couldn't do this little trick. I'd have to do the multiplication way. All right, so I take my two quantities, and this is so simple. The 8x becomes my firsts. The 5 becomes my lasts. Since it's positive, I use this sign twice. Are you thinking, what happens if it's negative? Well, then it's not a perfect square trinomial. Okay? It won't work. It's got to be positive in the back. Okay. So number 7 and number 8 look different as well. Oh, by the way, I should write that down. These 5 and 6 are called perfect square trinomials. And they can make your factoring much, much quicker. All right. These two here have perfect squares in them. And subtraction. These are called the differences of perfect squares. Well, let's see how these factor, because I can factor these even quicker than I can do those. Is this 16x squared a perfect square? Perfect square? Sure it is. Square root is 4x. 9 is a perfect square. 3. We've got a minus in the back. 4x plus 3. 4x minus 3. I have to have one of each sign, right? There you go. Now, if you go to FOIL this, you'll notice the inners and outers cancel each other out. I got a positive 12x, and then I have a negative 12x. Notice that's 0. And also notice there are 0 x's in this binomial. Okay? This is called the difference of perfect squares. when you have a perfect square minus a perfect square, it can factor that simply. All right, let's try it one more time. 25x squared, is that a perfect square? Sure is. 36 is a perfect square. 6. Is there subtraction? Yes. 5x minus 6 times the quantity of 5x plus 6, and I am done. It's a lot easier than multiplying 25 times 36 and trying to go through all the steps. Okay, so we will get some practice with this on Monday. Mr. Lawrence signing off. Have a good night, everybody.